what you need to know. You get that now? But basically, we're going to look at area and perimeter. That's the basic. So, but let me just give you the general formula needed. Believing that you know some basic information about measuration in O level. Now, let's say this is O, this is A, and this is B. So OA and OB are both radii, and arc AB has that length L. Is that clear?
Yes, sir.
Now, the length L, arc AB equals L, and that is equals to R theta. R theta. That is the radius times the angle subtended at the center of the sector. So that's the formula for length of arc. Now, this is simple. Is from what you know in O level, in measuration. Length of arc equals theta over 360 times 2 pi r. You know that this is the formula in secondary school, O level. Now, 360 degree is equivalent to 2 pi radian.
Yes, sir.
No, don't put your phone in speaker, please.
Okay.
So that I won't be hearing myself again. Can I move on? So if you replace this 360 degree with 2 pi, you now have L equals theta over 2 pi times 2 pi r. So 2 pi, we cancel 2 pi. So you now have L equals to theta times r, which is r theta. That is how we obtain this. Is that clear? Sorry, hold on. Let me place this lamp. There's no light again. So you have theta as the angle subtended at the center. So this is the formula for finding length of arc. Now, you can also find the area of the sector AOB. Now, for the sector, the area is 1 over 2 r square theta. That's the formula for finding area of the sector. Now, the proof of that is this. Remember, in O level, area is theta over 360 degree times pi r square. By the same argument that 360 degree is equivalent to 2 pi, so this will be theta over 2 pi times pi r square. So pi, we cancel pi. So we'll be left with theta over 2 r square. So that means area is 1 over 2 r square theta. So that is how this is obtained. Is that clear? So if you are asked to find, the area of, the perimeter of the sector, OAB, and you know that perimeter is total distance around the boundary of the plane shape. So the perimeter will be OA plus OB plus arc AB. So which means R plus R plus L. 2R plus L. L is R theta. So perimeter of the sector is 2R plus R theta. So these are basic things you can be asked to do. But beyond this, questions can come in diverse way. And of course, you need previous knowledge of measuration, of other shapes in measuration. Is that clear? So the shape of the problem at hand will dictate what you will do, how you are going to navigate. Yes, you can. You can factorize R, yes. Yes. So you can say it's R into 2 plus theta, if you so desire. Yes, you can do that. All right. So are you done with the writing? Okay. So let's see this example. This question we are given okay. Sorry, I'm trying to pick dashed line. Sorry. I want the line to be perpendicular. So it's not giving me the desired result. Let me use freehand. So there is a perpendicular here. Right? Then you have this. Yeah. So A, B, C, D, E. Then this is 8 centimeter. So this place is now shaded. So that place is shaded. So draw the diagram quickly. Then you now write the statement that follows. So the question says, the diagram shows triangle A, B, C, which is right angled at A. Yeah. So this angle here is 90, which is right angle at A. Full stop. Angle ABC equals 1/5 pi. Angle ABC is 1/5 pi radian. And AC equals 8 centimeter. Point point C and D. Sorry, point D and E. Points D and E lie on BC and BA. Lie on BC and BA. Respectively. The sector what's the sector? The sector ADE. The sector ADE, excuse me, is part of a circle. Is part of a circle with center A and is such that BDC BDC is the tangent to the arc DE at D. So question A. Find the length of AD. Question B. Find the area of the shaded region. Find the area of the shaded region. So please write the question quickly. So when you're done, let me know. Okay. So I'm going to scroll up while we see the solution. Now, the first part of the question says we should find the length AD. So to do that, what do you think we will do? Looking at the diagram, you have a triangle, and inscribed in that triangle is a sector whose center is A. Now, the sector is ADE, and that suggests that the radius of the sector, because we are told that is a part of circle, if you look at the statement closely. Is that clear? ADE is part of a circle with center A. So that suggests that since the center of the sector is at A, that suggests that AD and AE are both radii. AD and AE are both radii. So the first part of the question that says you should find AD, when you do that, you have invariably find the radius of the sector, or you want to say the radius of the circle, whichever way you want to put it. Now, to find that, I will need to find angle ACB, or you want to say BCA, whichever way you want to navigate. ACB. I will need to find that angle, this angle here. Let me use another color to show that. Let me use black. So I will need to find this angle here. That's angle ADC, ACB, or you want to say ACD. In other words, this angle C. I will need to find this angle. So to find that, I will need to use what? My trig ratios. I will use my trig ratios. Am I communicating? Now look at this. This angle has been given from the question that angle ABC is 1/5 pi. So this angle here is pi over 5. So I can say that ABC, angle ABC plus angle BAC plus angle ACB equals pi. Now, pi is equivalent to 180. Am I communicating? Considering that triangle ABC, so this is sum of angles in a triangle. So angle ABC, that's angle B, which is pi over 5, plus angle BAC. From the diagram, you have been told that angle BAC is 90. This angle here, 90. So that's angle BAC. So plus pi over 2. Hope I'm communicating. Plus ACB, angle C that I'm looking for, equals pi. So ACB will now be equal to pi minus pi over 5 minus pi over 2. Okay, how is BAC equals 90? Is there in the question? I'm coming. The diagram shows triangle ABC, which is right angle at A. Have you seen that? The diagram shows triangle ABC, which is right angled at A. So that is how BAC is 90. Is that clear? Okay. So work that out. You will see that that angle will be what? Now, your calculator must be in radian. Your calculator must be in radian function. So pi minus pi over 5 minus pi over 2 will be 3 over 10 pi. 3 over 10 pi. So that means angle C is 3 over 10 pi. So with that angle known, it's easy now to now find AD using SOHCAHTOA. SOHCAHTOA. Now, the angle we are looking for is that we have just determined is here. That's angle A. Angle C rather. So that means AD will now be opposite. Then AC is hypotenuse. So we know opposite, we know hypotenuse. So that means we are going to use what? From the SOHCAHTOA, which one will be appropriate? That's sine. The first one, the so. So opposite over hypotenuse equals to sine theta. So this implies that AD over AC equals to sine ACB that we have just found now. So AD will now be equals to AC times sine ACB. So AC, which is 8, AC is 8 times sine 3 over 10 pi. So if you evaluate that, you will get 6.47. It's okay. So that's the value of AD. AD is 6.47.